Hi guys, here's the last video for chapter 1. That's going to be dealing with rational expressions, which are expressions that are fractions. So you can kind of see an example of a rational expression here. We're going to be using a lot of factoring while we do this, so just kind of be aware and be prepared for that. It's a big part of this lesson, so we'll try to make that as easy as possible. But a lot of it deals with just reducing fractions type thing, finding ways to make the problem smaller before you go ahead and do what it says, whether it says, multiply or divide or add or subtract, like how can we make the problem simpler before we go and do those things. So a lot of that has to do with reducing fractions. So um, to kind of get going, to simplify these expressions, it's going to deal with factoring. So let's factor the numerator and denominator and look for any common factors to divide out. And so with something like a here, so we have x minus 6 over x squared minus 36. And so we want to factor the numerator and the denominator. And so, x minus 6 does not factor, so we just leave that alone. But x squared minus 36 is a difference of squares. And so that would factor into x plus 6 and x minus 6. And once we have everything factored, we go and look for things that cancel. So like x minus 6 on top would cancel and x minus 6 on bottom. And since everything canceled out of the top, we would be left with a 1 up there. So we're left with 1 over x plus 6. We are final reduced simplified expression there. Things that we can't do, like look at the x's here, you're not allowed to just reduce them. You're not allowed to just reduce the 6's here. That out of here, that doesn't work. That's not okay. You need something completely common. X minus 6 is a term, and then here, going with that x minus 6. So similar problem here, x squared minus 6x minus 16 over x plus 2. I want to factor that numerator. So that's going to be my simple AC method, easy AC, as a lot of times what I call it, or shortcut AC. So I have my a times my c is negative 16, since that's just a 1. And then I need those to add up to be negative 6. So my factors of negative 16 add to be negative 6 are negative 2 negative 8 and 2. So since this is a 1, remember that means we can take a shortcut and go straight to the factors. We don't have to do the middle step. So x minus 8 and x plus 2. So just going off of the numbers here, x minus negative 8 and then positive 2. So those are the factors there. And then that's over x plus 2. And I'm putting those parentheses there, even though they weren't there, but sometimes visually it kind of helps to see that. So, and of course those x plus 2's cancel. And so we're left with a 1 on the bottom, which, of course we don't need. So that would just be equal to x minus 8. Let's reduce that. So this big note here, something I was just mentioning, this is a really, really common mistake with these. So really something that, to watch out for, just knowing that a lot of people make this mistake, kind of let you know that's just easy to think about, easy to do. So as mentioned earlier, these x's are not allowed to cancel. Okay. So remember, canceling is a division idea, and I can't cancel with division when there's addition or subtraction going on. So these do not reduce because there's subtraction and addition here. Whereas if I said something like 3x over 5x, now the x's can reduce out because this is multiplication, 3 times x and 5 times x. And division and multiplication have a relationship where they can work with kind of at the same time. So then you could cancel the x's out and be left with 3/5. And that's okay. But because this is multiplication, then I can reduce with division. But this is addition, this is subtraction. I can't reduce with division while those things are happening. Okay, so just being careful about that. Very, 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 very common mistake. So when we go to multiply rational expressions, right? So look at this, pretty complex problem here. If I was actually going to do this, like take this fraction times that fraction, I'd end up with a really gross problem after that. And so we don't want to do that. We want to find a way to simplify things first. And so that involves factoring. So the first thing we're going to do is factor everything that we can be factoring. Factor every numerator, every denominator, and look for any common factors. So pretty much like we were just doing. in the numerator and that can be divided out. So just like we were just doing, we were finding common factors that can be divided out. And then you're going to multiply what's left. So you're going to basically shrink the problem and then multiply what's left over. So, and then the final answer is going to remain in what we're going to call factored form. And I noticed when I was looking in the back of the book just to look at answers, how they were writing things, they were not leaving their answers in factored form. So if you're checking your answers in the back of the book, they might look slightly different than what I would expect you guys to do. It's pretty common practice to leave answers in factored form, so I'm not really sure why this author chose not to do that. So, but like I said, the first thing we want to do is factor everything. So I'm going to factor that, I'm going to factor that, factor this, I'm going to factor this. So looks like a lot of shortcut AC method because those A values are all 1. So this is going to equal some fraction times another fraction. So it's kind of setting that up. And I'll start on that top left. So I need factors of 30 that add to be 11. So like 5 and 6, and both positive. So x plus 5 and x plus 6. Then I'll move down to the bottom left. So then I need factors of 6 that add to be 5. So that would be 2 and 3. So x plus 2 and x plus 3. Then I need factors of 12 that add to be 7, like 3 and 4. So x plus 3 and x plus 4. And then I need factors of 16 that add to be 8, like 4 and 4. So x plus 4 and x plus 4. So I've done the first step. I've factored every numerator and denominator. Now I'm going to go look for common factors that I can divide out. So as long as it's on the top, it can cancel something on the bottom. So like here I have an x plus 4, and that it could cancel the x plus 4 right on top of it. Or I have this x plus 3 on the left side, and it can cancel this x plus 3 on the right side. So as long as they're on top and bottom, that's fine. And then it doesn't look like I have anything else that can cancel. And so looking at what's on the top, I have an x plus 5 and an x plus 6 on the left side. And then I have and on the bottom, I have an x plus 2 and an x plus 4. So those are going to go together. Those are just multiplying. But we're going to leave it like this. We're going to leave this in factored form. So really the reason we do that is because right now you can tell there's nothing left to cancel. All right, you can see very clearly that none of these have, this x plus 2 can't cancel with the x plus 6. These don't cancel each other. But if we did multiply them back together, so we'd end up with x squared plus 11x plus 30 over x squared plus 6x plus 8. Then it kind of comes to question, like, is this reduced? Is it not? Can I factor something out that would be, that I could divide out? And so in this form, it's not clear if it's done. Whereas in this form, it is clear if it's done. So that is why we want you guys to leave things in factored form. So, all right, so that's why we're saying that. Do that, please. So that's the big idea with multiplication, is that you want to factor everything. Factor, 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 factor. And then cancel anything that we canceled. Again, as long as it's on top and on bottom, that's fine. It doesn't have to be right to left. It doesn't have to be straight up and down. Just as long as it's on top and bottom, that's enough. Okay, so here we had an example of both. One where one was on the right side and one was on the left side, and then one where they're both on the right side. That's fine. So dividing rational expressions is really pretty much the same thing as multiplying, right? Just as before. We got to factor everything, except there's one step we have to do right at the beginning, and you guys should be pretty used to that for dividing fractions. If I say something like 1/2, divided by 5/8. It's really hard to think about, so instead we do 1/2 times 8/5. All right, and so that's what that's equal to. So it'd be 8/10, which we could then reduce, but yada yada. So it's just that idea that we have to rewrite the problem first in order to do it by multiplying by the reciprocal of that second fraction only, right? So we only flipped that second one, right? I didn't flip the 1/2 and the 5/8. I just flipped the second fraction. So that's really what we need to be doing here. Sometimes, depending on how your brain works, if you want to, write the problem down, and then you're going to have to rewrite it as a multiplication problem. So fraction times a fraction, but this time, we're flipping that second fraction. And then you're going to go into your factoring step. All right. You can take those kind of, 2 steps. I really prefer to do my flipping and my factoring at the same time. So I got to be really careful that, as I'm writing stuff down, I make sure that I flip that second one as I'm doing the factoring. So it might behoove you to, take steps where you rewrite it and then factor it. But if you think you can hold on to everything and get into the right spots, you can just go ahead and factor, then flip at the same time. So make sure you're flipping that second fraction. Make sure you're switching this to a multiplication. I've seen people flip this and then leave that as division, so that doesn't really do us much good. So let me clean that up a little bit. So I'm rewriting this as a multiplication problem. So fraction times a fraction now. And I need to factor this, factor this, factor this. Right. And so then this will stay here, that will stay there. But now my red one's going to go to the bottom, my orange one's going to go to the top. So looking at that top left, that's a difference of squares. So I need, square root of 9x squared is 3x, square root of 16 is 4. So I have 3x plus 4 and 3x minus 4. Just looking at it for easy ones, I see that bottom right is easy AC. So that's going to be factors of negative 14 that add to be 5. So something like x plus 7 and then x minus 2. Those would multiply to be negative 14 but add to be 5. And then the other ones I'm going to do full AC. So I usually end up having to write that down. Otherwise I'm spending a lot of time in my head trying to keep track of numbers. But so the blue one here, 3 times negative 28, so that's what, 60, 24, so 84, so negative 84. So I need factors of that add to be 17, 184, 2 and 42. 3, so that'd be 14, 2, 28, 4 and 21. Oh, there's a 17. So I would need negative 4. Oops. I need negative 4 and positive 21. So 3x squared minus 4x plus 21x minus 28. Sorry about the handwriting there. Fix that. Break that in half. Those both have an x in them, so that'd be 3x minus 4. Those both have a positive 7 in them, so positive, make sure you got your plus there. And that'd be 3x minus 4 again. So that would be 3x minus 4 times x plus 7. We'll do the last bit of work up there instead of writing it again. And then I'm going to go to the red one. So of course 3 times negative 8 would be negative 24, and need to add to negative 2. This one's easier. Factors of negative 24 that add to negative 2 would be negative 6 and 4. That was easier since it was 24. So that'd be 3x squared minus 6x plus 4x minus 8. Break in half. Both those have 3x in them, which would be x minus 2. 4x and negative 8 both have a positive 4 in them, which would be x minus 2. And so that would give me x minus 2 and 3x plus 4. All right. So a lot of factoring. Then we go to canceling. So notice here I have a 3x minus 4 on top, 3x minus 4 on bottom. Then we got 3x plus 4 over here on the top left, 3x plus 4 on the bottom right. We got an x plus 7 on the bottom left, x plus 7 on the top right, and x minus 2 and x minus. So I cancel everything. All right, so that means I end up with 1 over 1, which is 1. So that happens sometimes. Just kind of showing you that you can. So nothing special, certainly don't end up with 1 all the time. But just showing you that you can cancel everything. End up with 1. So there's division. Again, pretty much the same as multiplication. Just make sure you're flipping that fraction and then turn it into a multiplication problem so you can do it then. So, right to there is oops, sorry, is this the, that idea of multiplying by the reciprocal with the division. So we could rewrite this problem that we did earlier, 1/2 divided by 5/8. It could be rewritten as 1/2 over 5/8, like a fraction over a fraction. They mean the same thing. And so we know to just bring this up, but flip it as we do that. So just something to think about. We've kind of done this already. So adding, subtracting fractions, of course, is more difficult than multiplying, dividing fractions because we need those common denominators. So adding, subtracting fractions, rational expressions, is just like adding, subtracting regular fractions. We need common denominators in order to do that. So just a quick reminder, if I wanted to take 3/8 minus 5/6, I'd have to say, well, what number do both 8 and 6 go into? That'd be 24. So I'd be multiplying 8 by 3 to get 24, so that means I need to multiply the top by 3 also, and be multiplying 6 by 4 to get 24, and multiply the top by 4 also. So I'd end up with 9 24ths minus 20 24ths, which of course would be negative 11 24ths. So find a common denominator, then you can do the adding or subtracting on the top. And of course the denominator stays the same, and then you would check to see if you can reduce your fraction after that. 11's prime, so we can't do anything there. So find common denominators. In order to do that with these more complex problems, right, a lot of times we need to think about how do we find that least common denominator. And well, guess what? The key is factoring. So we need to factor all the denominators. So only denominators this time, right? So just only the denominators need to be factored in order to make that least common denominator, or LCD. So least meaning that it's the smallest, because that'll make the problem the simplest if we can find the smallest number they both go into. Common meaning same. So what's the smallest same denominator? So the smallest number that 64 or 6 and 8 can both go into would be 24. Could have said they both go into 48. Could have said they both go into some other giant number like 96. But that's just gonna make the problem bigger and then make me reduce it later. So if we can go with that least one, that means the least amount of reducing later on. So as we look at something, should be pretty simple, like A here. Trap you gotta avoid falling into, saying what do these have in common, is thinking that they both have an x. Okay. So remember that these ideas are division, multiplication ideas, and since this is an x plus 5 and an x minus 3, I can't peel that away in any way that would that would say, okay, I can just talk about the x and the 5 separately. So this is all one term, or one expression here. I can't break them apart with multiplication or division. And so in the same way here, I can't break those apart with multiplication or division, so they're kind of stuck together. So in order to make them common, I would actually have to multiply them by each other. And so this would be x times, you would need to multiply the bottom here by x plus 5. And I would need to multiply the bottom over here by x minus 3. And now if you look at the denominators, now the denominators are the same. They're both x minus 3 times x plus 5. Right? But I can't just change the denominators, I also have to change the numerator in the same way. So this would need to be multiplied by x minus 3, and this would need to be multiplied by x plus 5. So the real common thought is that they both have an x, but they don't, because of the addition and subtraction. So, but now they have the same denominator. So I'm going to make one big fraction, x minus 3, x plus 5. I'm going to bring this down and do that math, right? Of course, x minus 3 times 3 is 3x minus 9. But because I brought it all down at once, I need to put it in parentheses. Then I have my minus sign. And then I'm going to bring this down. So 1 times x plus 5, of course, is x plus 5. But I'm bringing that all down at once, so it needs to be grouped, right, in parentheses. And now I need to do this, right? 3x minus x, negative 9 minus 5. All right, so I need to be really careful about my subtraction here. Subtraction is often tricky. So my denominator doesn't change, just like on the 24s above. So x minus 3 and then x plus 5. Remember, we're going to leave that in factored form, so I do not expect you guys to be multiplying those together. And then 3x minus x, of course, is 2x. And then negative 9 minus 5 is negative 14. You might notice that the numerator is factorable, so that could be 2 times x minus 7 over x minus 3 times x plus 5. So there wouldn't be like a truly factored form, because then we would see that this x minus 7 doesn't reduce anywhere. So that would truly be the factored form. But I think if I can get you guys to get here, that's probably where I'd expect you to finish. But this would be kind of like, you really know what's going on if you could do that. So, so I didn't have to do any factoring there, because these denominators already, as simple as I can make them. So, or not simple, but they were simple denominators. They weren't products of anything. So, whereas here, there's some factoring I'm gonna have to do on these guys to check to see what's going on. So, maybe this one will be a little clearer on what's how we have this idea of like things being, what's common and what's not. So rewrite the problem. So plus 2 on the numerator, y on the numerator. So y squared minus 16, of course, is the difference of squares. Y minus 4 and y plus 4. Y squared plus 7y plus 12 is a simple AC, easy AC, shortcut AC problem. So I need factors of 12 that had to be 7. I think we did that one earlier. Y plus 3 and y plus 4. So now we have something in common when we look at the two denominators. And hopefully you notice they both have a y plus 4. And because it's y plus 4 times something, right? We can look at that like as an individual thing. Here's a y plus 4 they both have. And then, okay, well this one has a y minus 4, but this guy over here doesn't. All right, and this one has a y plus 3, but the one on the left doesn't. So we can kind of see what they do have in common. And once you know what they have in common, you actually ignore it. It's really the differences that you're trying to highlight. So the left one has a y minus 4, the right one doesn't. So that means I'm going to go over here and give this a y minus 4. And then the right one has y plus 3 that the left one doesn't. So that means I'm going to go over there and give it a y plus 3. And now you can see that they do, now the denominators are the same, right? A y plus 3, a y minus 4, y plus 3, or y plus 4, y plus 3, y plus 4, y minus 4. All right, so they do have the same denominator now. Of course, I can't just change the denominator. So the numerator also needs a y plus 3. The numerator also needs a y minus 4. So as I go to rewrite the problem, I'm going to make one big denominator. It does not matter what order you write these in, just that all three of them are there. And then I'm going to look at this. It's going to all come down at the same time, so I'm going to put it in parentheses, 2y plus 6. And then I have my plus sign from the problem, and then this is all going to come down at the same time, so it's going to be in parentheses, so y squared minus 4y. And then I'm going to do that addition on the top. Right? So again, the denominator is not going to change. Leave it factored. Do not waste your time multiplying together. So I have a y squared. That's my highest term. And then I have a 2y plus a negative 4y, so 2 plus negative 4 being negative 2, so negative 2y. And then I have that plus 6. I could check to see if that's factorable, to see if something does reduce out. So I'd say, what are factors of 6 that add to be negative 2? And there are no factors of 6 that add to be negative 2, so this is a prime expression up here, so can't factor that, so that means nothing here will reduce out of that. So that would be as far as we could take that. So again, I've noticed what they have in common, but then really kind of ignore it. and I say, hey, what's different? This left one has a y minus 4, so this needs a y minus 4. This right one has a y plus 3, so this needs a y plus 3. So you give it what it doesn't have so that they can be the same. All right, so it's about giving each denominator something in order to make it the same as the other one. Don't take something away. So, I think an example I don't see here, I just want to do real quick, will be something like 17 over x squared minus 9 over 4x. Okay, so how do I do that? So if I think about it, 17 over x squared is the same thing as 17 over x times x. So if I kind of think like in a factoring way, right, if I factor that bottom, and then 9 over 4x would be the same as 9 over 4 times x, right? So as I kind of break things apart and look, say, well, what do they have in common? Oh, they both have an x. But what does the left one have that the right one doesn't? Oh, it's got an extra x, right? So I need to give an extra x over here, right? And so let's go get an extra x. And then what does that right one have that the left one doesn't? So, oh, well, it's got a 4. That means I want to give it a 4 on the left side. And so now we see that the denominators are the same, right? 4xx, 4xx. Well, you can't just do it to the bottom, you got to do the top. So that's going to be multiplied by 4. This is going to be multiplied by x. So 4 times 17 being 40 plus 28, so 68. Then minus, and then 9 times x, of course, being 9x. Notice I'm not putting parentheses on there because 68 isn't something complex. 9x is not something complex. Not like 3x minus 9 was. That was like multiple things coming down at the same time. X plus 5, multiple things coming down. This is just a number. That's one term right there. So I'm just bringing one term down. So I'm not worried about like parentheses, but you could put them in if you wanted to. And that'd be over 4x squared. And then technically that x term should be in the front, so it'd be negative 9x plus 68 over 4x squared. And if I wanted to see if it was reducible, ooh, that's fun. What I'd be looking for is, do they all have something in common? Now, these two have x's, but that doesn't have an x. These two are divisible by 2 or 4, but that one's not. So they don't all have anything in common, so I cannot reduce that. So that's how you deal with like monomial denominators. So if you need to kind of think about it that way, like this one has 2 x's, but this one only has 1, I better give this guy an extra x. This guy has a 4 that this one doesn't, so I better give him a 4. So kind of think about that, just that language, like what can I give them to be the same? Let me group this stuff up. So that's the idea there with a problem like that. I better group this to the page. Okay. All right, last thing is called a complex fraction. And this is actually the first time I've taught these. This is kind of fun. So you notice what a complex fraction looks like is fractions within fractions. So to simplify a complex fraction, first we simplify that numerator and denominator by doing the adding and subtracting. So just wherever that's needed. So you can see on this example, there's some subtraction we can do on the top before we do that. And then we're going to finish the problem by doing what we did earlier, which is mainly whatever. So we're going to simplify the numerator first. This is doing this now is actually going to do it a different way than I normally do it. Normally I just go ahead and deal with the fraction at the bottom first, but kind of is whatever. It doesn't really matter. So if I just kind of focus on the numerator though, say I want to simplify that since there's some subtraction, and say, well, I want to subtract those, they better have the same denominator, and they don't. All right, so it's like we were just doing, what's one have that the other one doesn't? Well, this left one has a y, the right one doesn't, so I'm going to give it a y. Well, whatever I do to the bottom, I better do the top. And the right one has an x that the left one doesn't, so I'm going to give it an x on the left. So what I end up with is x times x, or x squared, minus y times y, or y squared, over, all right, what's the denominator now? All right, it's xy. And then this is still over y. Okay. So at least we've taken the numerator and smushed it down into one fraction instead of two fractions that are being divided by this. So may not seem any simpler, but it actually is, since it's just one fraction instead of two. And you got to avoid that urge to cancel these x's or cancel these y's, because remember this subtraction here says no, you are not allowed to divide. Okay. So now I have this here. So now I want to basically take this bottom fraction, this bottom denominator, and get rid of it, and instead multiply by its reciprocal. So if I think about what's the reciprocal of y? Well, remember y, it could be written as a fraction as y over 1. So instead, we're going to take this and say, well, that's equal to x squared minus y squared over xy times, and take this and flip it, 1 over y. And just do the multiplication, top times top, so x squared minus y squared times 1, of course, is just x squared y squared. And bottom times bottom, y times y would be xy squared. And again, fight that urge to do any reducing. Okay, it's not okay because of that subtraction there. They would all have to share something in order for that to be reducible. So this is actually the answer. So what that could look like if it was reducible would be something like this. If you had something like 5x squared minus 10y squared all over 15xy. Now this is reducible because all three terms are divisible by 5. And so that could be reduced into x squared minus 2y squared over 3xy. But notice how none of the variables reduced, because none of the variables appeared in all three terms here. So all three spots. Yeah, so that's that lesson. Definitely a tricky lesson. Definitely a lot of work with all the factoring. I think this assignment, the homework that's right down here is fine. I would just tell you guys to not do 29. It was just a little bit too much as I was doing it. It just was kind of a real bear of a problem. It wasn't anything particularly hard. It was just a lot of work. So you'll go from 25, and then you would normally do 29, and then you would do 33 after that. So just skip 29 and go straight from 25 to 33, and then to 37. So so just changing it a little bit, so make it a little bit simpler for you guys. I'll see you guys in class.